Well, welcome back everybody. In this video, what I would like to do is to do something slightly different. That is to say, I'm not going to look at specific pieces of Python or Python syntax, but in this video, I would like to take a little simulation game and I would like to talk through the design process. So I'm going to talk about how I would lay out things like variables and what kinds of data structures I would choose, what kinds of logic structures I would choose to get that to work. And then I will work it up to some pseudocode. So I will not convert it into pure Python. And in fact, I will leave it at pseudocode and I will let you do that on your own to complete the game so that you can play it on your own. So let's get started. Let's take a look at the little simulation game that we're going to be working with today. So we've got a raucous evening at the pub, and one of the tipsy bar patrons is going to walk home, and here down below is the map that he's going to use. So he starts at the pub, which is in the upper right hand corner, and as you can see, as he enters every square, then he has a possibility to go to a different square. So he can choose a random direction when he gets in the square. And the goal of the simulation game is that we want to let him wander around randomly until he gets to his home, which is in the bottom left corner. And all we want to do is just count how many squares he goes through. And of course, we can run the simulation many, many times. We can calculate the average length of his walk. And then down here is some other alterations that you can make. We won't talk about those today, but if you want to come back and try this, go ahead. You can change the size of the map grid, or you can reduce the number of entrances and exits. You could turn it into a maze if you wanted. All kinds of crazy things you could do once we get the basics down. So the first thing let's do is let's just keep track of the variables that we will need. That is to say, what are the things that we need somehow to keep track of? Well, obviously one of the first ones is that we've got this guy who's wandering around. So maybe you might think we have a person. Technically speaking, it isn't really the person we need to track. It's actually his location. So location is one of the things that we need to keep track of here. The characteristics of the person himself or even herself don't really matter. It's just the location that we need. So location's one of them. Obviously, the whole goal of the simulation is to count how many squares he enters. So we'll have to keep a count of the number of moves, right? And so every time he moves, we're going to add 1 to that number. So that's something that we're going to be incrementing. And then obviously at the end, that's the thing we really want to know, right? How many moves did it take? I think the reason that sometimes students avoid this particular puzzle is because the map looks really complicated. And in fact, this might be the secret, if there is one, to this puzzle, which is that I need to choose a data structure in Python that allows me to store that map and to do so simply. And in fact, if I choose a good data structure, my code will be very, very simple. If I accidentally choose a bad data structure, my code gets a little more complicated. And so for me, when I'm programming, if I get really complicated code, I start to rethink my decisions about data structures. Now, in this one, it looks like it's a 2D data structure. We might want to think of it as a matrix maybe, but there's a hint here, which is that all the squares are sequentially numbered. 1 to 15. And so square number, 7 is identified only as square 7, not that it is in row 2, column 2. So that gives me a little bit of a hint that even though this looks like a two-dimensional structure, I probably can store it in Python as a one-dimensional data structure. Now that map does have some coordinates on it that are important, and I'll need to set those up at the beginning as well. So right now, at least in this version of the map, the pub is on square 5 and his home is on square 11. So somewhere in my script, I'm going to have to define that the pub is on 5 and the home is on 11. So if I choose a good data structure, and here maybe a linear one like a list or a dictionary, If I choose a good data structure, then it might help me simplify some of the other complexities of the game. So one of the things that's going to be really important is his ability to move to other squares. So let's just take a look at that and draw a couple of pictures, and that might help us understand how to arrange the data structure. So if he happens accidentally to be in square number 1, he can only move 4 directions: north, south, east, west. And here he can only go, as it were, east and south. So from number 1, he can only go to squares number 2 or 6. Those are the only ones that he can go to. So if I think about this data structure as a filing cabinet rather than as a grid, if I open drawer number 1, I should only see the options 2 and 6. Well, that makes sense. If I open drawer number 1, maybe 2 and 6 is a list that is the contents of drawer number 1. Well, let's imagine if he's at, say, 4, he can go to square 3, or he can go back to the pub, which is on square 5, or he can go to square 9. So if I open drawer number 4 in the filing cabinet, I should see the options 3 and 5 and 9. Similarly, the same thing here is a little more complex, right in the middle of everything. If he happens to be in square 8, then he has 4 choices to go to. He could go to 3 or 7 or 9 or 13. So if I open drawer number 8 in my filing cabinet and I see the list 3, 7, 9, 13, all I have to do is to choose one of those options, and that's his next square. So I think a list and a dictionary, or both, one of either, makes some sense here. I want to start with doing this as a dictionary. So here's my map, and you can see I've got a curly bracket at the top and a curly bracket at the bottom. That tells Python it is a dictionary. I have my key value pairs here. Remember, that's the secret sauce for a dictionary, is that key value set. What might seem different to you here is that the keys are not strings. Here, those dictionary keys are integers. So I need to kind of confess, it's possible to have a dictionary that doesn't have strings as keys. And in fact, the real secret of a dictionary is that the key is an immutable data type. Strings, as we know in Python, are immutable, and so those are probably the most common dictionary keys that you'll find. But integers are immutable too. Like if I take the integer 5 and I add 1 to it, I haven't changed 5, have I? I've just gotten a new integer number 6. So dictionary keys are just immutable. I could put tuples in there too, and so this is one way I could create very complicated keys for a dictionary. But the key, see what I did there? the criterion really for a dictionary key is that that data structure type is immutable. Strings, classic immutable data types. Integers, also immutable. Tuples, also immutable. All of those are possible. So I'm going to use here the integer as a key, and the integer is going to match the square on the grid. Now, when I open up that drawer, when I look at the value of that key, I have a little tiny list, and that little tiny list is the adjacent squares that are legal moves for my dude as he's wandering home from the bar. And again, it's a comma-separated list, so you'll notice after in drawer number 1, after 2, 6, there's a comma, and drawer number 4, 3, 5, 9, there's a comma. And I've got a lot of dots here, so I'm going to leave you to fill out the rest of that particular dictionary. Now, that's one option. I could also do this as a list. So let's take a look at how I would do this as a list. And again, when you're writing this code, turning it from pseudocode into Python, you may actually want to try it both ways. You should get the same results in the game, but the code will be a little bit different for you depending on which of the two data structures you've chosen here. Obviously, one of the most telling things about a list is that we don't have the indexes, that lists are automatically indexed by Python. So here we don't need to specifically identify the square or the drawer that we happen to be in, because Python's going to do that automatically. But one of the hitches about a list is that we know that a list starts at 0. So I need somehow, if I choose this data structure, I need somehow to account for that 0th drawer. I won't ever access it, so whatever I put into the 0th drawer doesn't really matter. So maybe in this case, I may choose to put none in there. Whatever I put in there is going to be irrelevant because I'm never going to access it. But you'll notice that these are actually now numbered, or they will be numbered automatically by Python in exactly the same way that they were for the dictionary. So drawer 1 will still contain 2 and 6, drawer 4 still contains 3, 5, 9, drawer 8, etc., etc., etc. Now, for me personally, I kind of like the dictionary better because I can see those relationships more clearly. If I wanted to know what is in, say, drawer number 11 in the dictionary, I can see it pretty quickly. But here I'll need to count my way down to figure it out. Now, does it matter? Absolutely not. So if you want to write this as a list, that's okay. If you want to write it as a dictionary, that's okay too. But our choice of a data structure will have some, maybe minor, changes in the code. And here's one of them. If I choose a list, I need to account somehow for that 0th drawer. All right, so let's think a little bit about the logic, or maybe we could think about it, the algorithms about how we're going to run our game. Obviously, we've got the map, and that's kind of the playing board here. And we already know now that I can do that as either a dictionary or a list. The choice between those two is pretty much up to me, so I can choose one or the other, and that's totally fine. As he enters every square, he moves to a new one randomly. So what that means is that I will probably have to, not probably, I will have to bring in the random module so that I can have Python choose things randomly. Now, how I want to do that is that I will give some function the drawer, and random should look inside that drawer, figure out what those contents are, and choose one of those options. So that's kind of how I want that to work. So I'm going to give it the key. The key is its current location. And then random should look inside that drawer of the filing cabinet and choose one of the options that it finds inside. Fortunately, as you may have guessed, random has a way to do that. So random has a function called choice. And what I send to choice is a list. So here I just did this on the Python interactive shell. I sent to choice a little hard-coded list of 3 and 5 and 9, and I just happened accidentally to get back 3. If you choose this, or if I did it again, I'm sure I would get 9, and then I get 5, and I get 9 again, and 3, so etc., etc., etc. So random.choice seems like my best option here. If I send it a location in the map, what I want to do is to send to the choice function my map drawer number 4. And the contents of drawer number 4 become the list of things that choice will select from. And of course 4 here really is just its current location, right? So 4 is not going to be hard-coded. 4 is going to turn into a variable. And that variable I will probably call location, because that's where the guy is right now as he's going home. So if location happens to be 4, then the variable will resolve to map drawer 4. It will send that list to choice. Choice will give me one of those options, right? All right. The second thing, and maybe this is where you wanted to start, this is fine if you did, is that this is a loop, and we have to continue allowing our guy to wander around the map randomly until some condition is reached. And that condition is that he has arrived at home, which in this version of the map is square 11. So this is a repetition, it's a loop, and I don't know how many times it's going to take him to get there. And because I don't know, it's a while loop, right? So I'm going to continue looping while he's not at home. That is to say, while his current location is not equal to square 11. And as long as that conditional is true, then I need to keep picking random squares and sending them around the map. All right, just to sum up then, here's really the pieces that we need before we can sit down and write that pseudocode. Obviously, as we were just talking about, I need a variable maybe called location. You could call it something else if you wanted to. And all that registers is where is the guy right now. He'll start at the pub, he'll end at home, but in the middle, we just need to know where he is. I also need to track the number of moves that it takes him, and obviously that's going to start at 0, but I'm going to just add 1 to that variable every time he makes a new move. Now, adding 1 is sometimes just called incrementing, so you'll hear that term as well. Now, the map is maybe the secret sauce to this. If I choose a good data structure, my code is going to get really, really simple, and that's one of the litmus tests for choosing good data structures. But I've decided that I could work this either with a list or a dictionary, that is to say a filing cabinet. And when I open up one of those drawers, what I see inside is a list of potential next squares or potential moves. And then I'm going to identify the square that is the pub and the square that is his home. Now you'll notice I put those in capital letters. Python doesn't really have the concept of a constant, which is a variable that doesn't vary. But sometimes by convention, we create variables in Python and we give them capital letters. And what that tells us is that these variables are behaving as if they are constants. That is to say, the pub doesn't really move. It's always going to be on square 5. Home doesn't really move. It's always going to be on square 11. So technically, I could do these as lowercase variables, but I often use capital letters to signify variables that shouldn't change, or sort of called constants. And again, Python doesn't really have the concept here of a constant, but by convention, when I see a variable that's in capital letters, I know there's a secret arrangement there, or a guarantee, or a contract, or an agreement that I shouldn't go messing around with those variables. Once they're set, leave them alone. All right, but some of the logic things that I need to do then, obviously I'm sending him randomly around the board, and so I have to import the random module. We've already talked about that a little bit, that Python runs lean and mean, and it doesn't always load everything that Python has, and random is one of them. So at the top of my script, I'm going to have to import the random module. But random has a function called choice, which is a really easy way to choose the next square. So I'm going to use choice as a way to send him around the board. My loop, obviously, is a while loop because I don't know how long it's going to take. So a for loop is not a good option for me here. Because I don't know how long it'll take, I'm going to tell the code to keep sending him randomly around the board as long as the condition is true that he's not at home. Now, when he is at home, that Boolean test is going to go false and my loop will stop. So this is really the litmus test. This is the Boolean test for how long I'm going to keep going. And then, of course, I'm going to add 1 to the total number of moves because that's what I really want to know at the end. How many moves did he make in order to get home? And just to repeat, number of moves plus equal 1 is the same as writing in Python number of moves equals number of moves plus 1. This is just a shorter way to do that, which you may like or you may not. There's no correct way to write that. So here's my pseudocode. So up at the top, I'm going to import the random module, and then I'm going to do a couple of preliminaries. I'm going to have to define that map, and again, this is the part that will take you the most time and care. You're going to have to sit down and track out manually where the guy is allowed to go given any square. And so that's going to be a big list, or it's going to be a big dictionary, but figuring that out is going to be the thing that's going to take you the most time here. I'm going to define where the pub happens to be. I will define where the home happens to be, and I'm going to do those as variables up top, because if I wanted to change the simulation and move the pub or move the home, all I have to do is change the numbers up there at the top of the script, and then I'm good to go. And then I'm going to define the status of the universe before my simulation begins. His current location is going to be the pub, and the total number of moves he has made is 0. And then I'm going to drop into my loop. And as long as his current location is not at home, I am going to move him. And we've already seen that's kind of easy now, right? So his new location is just a random choice of the list that happens to be in the drawer called location. So I can actually move him to a new square in one line of Python, and that's going to be very, very convenient. Now for me, that's a sign to me that I have chosen a pretty good data structure, because that code or the logic of moving him from square to square to square suddenly went to one line of Python. And so that reassures me that the data structure I've chosen is a good one, because it has helped me to solve a problem. It's taken what I think perhaps might be the most complicated piece of this puzzle, or the complicated piece of this game, but it has simplified it down to one line of Python, and that reassures me a lot. Now inside the loop, the other thing I always need to do, though, is I need to increment the total number of moves that he's made. And once I increment the number of moves, the loop flips back up to the top, and it checks to see if he is now currently at home. If he's not, we repeat. If he is, then the Boolean test of that loop fails, and we fall through to the bottom where we print the number of moves. So if you're thinking back to loops and the 3 parts of loops, they're all here, aren't they? This stuff up here is the initial status of the universe. That's the way the status of the game, the beginning of the game, the way the universe is before we start our loop. The while loop has a Boolean test. We continue as long as he is not at home. And when that Boolean test fails, then the loop is over. Now here, the degree of change is that he moves to a new location on the map. Now we do that at random, so we don't know precisely how many times we have to go through that loop, which is why we have our other variable, right? Number of moves, and that will count him up for us. So if you're wondering if the pseudocode has the 3 parts of a loop, it does. They're all here. Classic example of a loop. All right. Well, that's as far as we're going to go in this. So I welcome you to go turn this pseudocode now into some Python and run the little script and see how many moves it takes. Run it a couple of times and see what happens. And then if you want to play with it, you're welcome to do that too. Move the location of the pub, move the location of his home. You could even change the map a little bit. You could take away some of the possible maneuvers. You could make it a little bit more maze-like if you wanted to. You could even add some things like diagonal moves, which in the map as we've had it right now, we don't even have. But if you'd like to add those, you certainly can. That would even allow him to take a shorter shortcut on the way home, right? But you can try that out. All right, well, that's all we're going to do today for creating something in pseudocode. So I hope you can turn that into some real Python and then have a little fun playing with that game. Thanks.